Welcome to our next unit on trigonometry. We're going to focus on angles and standard position in quadrant 1. The coordinates of a point P on the coordinate plane can be described by its distance r from the origin O. So this would be O, your origin, and we're looking at some distance r from O, and it creates an angle theta that OP makes with the positive x-axis, which is over here. When the angle theta is between 0 and 360 is measured counterclockwise from the positive x-axis and is indicated by that green arrow. We call that this angle is in standard position. This ray from O to P, some point P at the end, this is called the terminal side. So this side over here is called the terminal side. And the point P is the terminal point of that angle. The positive x-axis is going to be called your initial side. That's along the x-axis. So that's what a terminal arm looks like. If we want to find out information about that terminal arm, we can create a right triangle with that. So in the second diagram, you can see that we still have our origin at 0, 0. We have some point P with coordinates x and y. The length from the origin to that point P is called r, which is our terminal side. We just closed off using this y here to create our right triangle. And our initial side is some coordinate x. So we need to recall some things from our trigonometry from the previous years. We're going to use the Pythagorean theorem whenever we have a right triangle and we're looking for a missing side. Then we also use sine, cosine, and tangent to either find a missing side or an angle in a right triangle. So as a review, I'm going to draw a triangle on the side here. This is your angle. This is your 90-degree angle. From this angle, theta, directly across on that side is called the opposite side. And the other side is called the adjacent side. That is adjacent to that angle. And the longest side is called your hypotenuse. So let's just say that I want to use sine. Sine theta is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So again, you're going to use sine, cosine, or tangent if you want to find a missing side or if you want to find a missing angle. So we're going to use the diagram below to answer the following questions. So r, again, is the distance from the origin over here to some point P with coordinates x and y. This distance of r from here to here is always going to be positive, and P is any point on our xy plane. We're going to write an expression for r in terms of xy. Whenever you see a terminal arm and you're looking for r, x, or y, we can always create a right triangle. I'm going to close off one side of it, and this would be our y value from the coordinate. And along the x-axis here, this would be coming from our x value of the coordinate. So we're going to express r in terms of x and y. If I knew what x and y is, I can just use the Pythagorean theorem to solve for that missing side. And now we can rewrite this, so we're solving for r. That means we can square root both sides. And this will give us the square root of x squared plus y squared. And that is how we're going to get r. If we want to find the angle theta, which is this angle in here, we can use either sine, cos, or tan for that. If we know what y and x are already, if we know the coordinate points, then we can use tan because that is opposite over adjacent. So tan theta is equal to opposite over adjacent. And if I want to solve for theta, I can take the tan inverse of both sides. And that's how we define our angle. But it did say express in terms of x and y. So opposite is y in this case, and adjacent is x. And the next question, we're looking for the x coordinate of P in terms of r and theta. Our x coordinate is the adjacent side, and r is our hypotenuse. So the trig ratio that has adjacent and hypotenuse is cosine. Our adjacent side is called x in this case, and our hypotenuse is called r. If I'm looking for x, I'm going to rearrange, so I'm solving for x. That means I'll multiply both sides by r, and this will give us r cos theta. We're going to do the same thing for y, but y is the opposite side now, and then we have r, which is our hypotenuse. Now we're going to do the same sort of thing, but for y. Our y is the opposite side, and r is the hypotenuse. So the trig ratio that has opposite and hypotenuse is sine. Our opposite side in this case is y. Our hypotenuse is r. Now if I want to solve for y, I'm going to multiply both sides by r, and we'll have y is equal to r sine theta. Let's try the next example. The points below are on the terminal arm of an angle in standard position. Determine the distance r from the origin, determine the primary trig ratios of theta, and also determine the measure of theta to the nearest degree. So we're going to draw our point 5, 7. They're both positive, so we do know this is in quadrant 1. And here's our point. And it's going to connect with the origin, 0, 0. So that is our terminal arm. Now can close it off and create a right triangle. So this is our y, and we know this is 7. This is our x, and we know this is 5. Our r is the distance between the origin and the point. And our theta is the angle between the terminal arm and the x-axis. Let's try to answer the first question and find r. We have a right triangle here with sides 7 and 5, and we want to find r. So I'm going to use Pythagoras. That's 5 squared plus 7 squared is equal to r squared. But I want to solve for r, so I'll square root both sides. And simplify, which is 25 plus 49. And that is 74. So that's r. I'm just going to leave it as is like this. Some cases you won't be using calculator at all, so if it's in radical form, you just leave it in radical form. The next thing we're going to do is write the 3 trig ratios. So that's sine theta, cos theta, and tan theta. So sine theta is opposite over hypotenuse. In this case, our opposite is the y value of 7 over r. And we found what r is. It's the root of 74. For cosine, that's adjacent over hypotenuse. Our adjacent side is 5. Our hypotenuse is r, which is the root of 74. Then lastly, we're going to look at tan, which is opposite over adjacent. Our opposite is 7, and our adjacent is 5. Lastly, we are going to find theta. We can pick any of these trig ratios to find theta and just take the inverse of it. So I'm just going to pick tan, So that's tan inverse of 7 over 5 after we take the tan inverse of both sides. This you'll need a calculator for. So if you want to find the tan inverse, remember to press second function tan and then 7 divided by 5. You should get 54.5 degrees. And if you don't, then check the settings in your calculator because your calculator may be in a different mode, either in radians or gradients. Moving on to the next question, we're going to plot the point 3, 4. Again, this is in quadrant 1, just because our x and y are positive. And then I'm going to make a terminal arm connecting with the origin. I can also close this off so I can create a right triangle and label my sides. To find r, we're going to use Pythagoras. Our x in this case is 3. Our y in this case is 4. That's 9 plus 16, which is the root of 25. And then r is 5. You didn't need to solve for this if you already knew that these are one of our special triangles for our right triangles. You're always going to get 5 for your hypotenuse if you have sides 3 and 4. Now we're going to find our primary trig ratios. So one for sine and then cos and tan. So sine theta is opposite over hypotenuse. In this case, our opposite is 4. Our hypotenuse r is 5. Cosine is adjacent over hypotenuse. Our adjacent is 3. Our hypotenuse is 5. And then lastly, for tan theta, that's opposite over adjacent, which is 4 over 3. Lastly, we are going to find our angle theta. And then we can just use tan again. So tan inverse of 4 over 3 will yield 53 degrees. So trigonometry is also used in navigation. A direction can be described by using a compass, north, south, east, and west. So a heading of west 30 degrees south means from a direction due west, rotate 30 degrees counterclockwise, or you can say towards south. So that means you're going to go west first and then south, which creates this angle of 30 degrees. A heading of west 40 degrees north means from a direction due west, we are going to rotate 40 degrees north. And that's how you get this angle of 40. So here's an example. A forest ranger sees smoke rising from a point that lies in a direction of east 40 degrees north. She estimates that the distance from the ranger station is about 30 kilometers. The firefighters at the ranger station have to travel east, then north to get to the fire. To the nearest kilometer, how far should the firefighters travel in each direction? The first thing we're going to do is draw a diagram. We've been given a piece of information here, east 40 degrees north. So that means we're going to go east first, and then north. And this creates an angle of 40 degrees. And this distance from the ranger station is about 30 kilometers, which is our R in this case. So our point P is the point where we see the smoke rising, and the forest ranger is at the origin. So the firefighters at the ranger station have to travel east, then north. We want to find how far should they travel east and how much they should travel north. We're looking for X and Y. Since we have the angle and we have the hypotenuse, that means we can use our trig ratios to find our X and Y. So if I'm trying to find X, if we look at our angle, we have the adjacent side and we also have the value for the hypotenuse. So I can use cosine. Cos of 40 degrees is adjacent, which is x, over hypotenuse, which is 30. Then I'm going to rearrange and solve for x. I'm going to multiply both sides by 30. So that's 30 cos 40 degrees. And then I'll put this into our calculator to see what our x value is, and that's 22.98. Our units are in kilometers. This is the distance. The next thing we're going to do is find y then. Y, in regards to the 40 degrees, is the opposite side, and then we have the hypotenuse. So we're going to use sine 40. Our opposite is y. Our hypotenuse is 30. And then I'm going to rearrange and solve for y by multiplying both sides by 30. So y is 30 sine 40 degrees, and then we'll evaluate this with our calculator, and we get 19.28 kilometers. To summarize our answers, because we do want to describe it in terms of the direction, that's what the original question said: how far should the firefighters travel in each direction? In terms of x, we're traveling east. So our final answer then would be 22.98 kilometers east. And then our y determines how much north we're going to go. So that's 19.28 kilometers north. And that is our final answer.